something like that.
He loads wanted to see and was ABC. I knew what that did, but I had no idea what he was supposed to do after that.
Oh, okay.
Basically, he was jumping if the lower speed was 0. But
Yeah.
yeah, but from after that.
Oh.
Yeah, I think I was starting to fall apart on this as well.
Alrighty. So I'm gonna turn on the projector. I cannot.
The hardest test I've ever taken was a math test that did this. 6 people started crying in the middle of the test.
I feel a lot better about myself now.
No, this was the second hardest test I've ever taken.
Oh.
The first hardest test I've ever taken was a math class at Davis. It was kind of like it was a big class, but during the final, 6 people started crying.
Oh.
And had to leave. So, and that was the first hardest. This is one better from that.
Really?
I say that means you're doing something right, but
If either you or I had started crying, it would have been right apart.
Okay.
I came close.
If Kat had started crying, then it probably would have been on the first one.
Hey, there's still time for that after you see something right.
I don't know. Yeah.
Well, let me explain the answers first, and then you guys can kind of decide, you know. Okay, it's my screen is not getting projected. See, it's all. No, okay.
Personally, I think it would have been a lot easier to look at things if I could have used like a spreadsheet program or something like that, just trying to do some of it on paper.
If I had this processor in front of me and I could like try running the code instead of just trying to step through it, so it did, that would help a lot.
Well, not even that, but I mean like even just having like a spreadsheet where I could go and adjust, oh, I need to put this here. It's like I could shift everything down rather than trying to write it in.
Oh, okay.
You know? Just digital is better than paper for this type of test.
Stack. Stack.
Yeah.
I cannot understand why sometimes it connects and other times it does not.
Is it consistently not connecting?
No, it has been working really, really well for the previous class. You know, in cisp310, it's working just fine, and you know, in this class, you know, it's not working.
It just hates this class for some reason.
It's really weird because if I click these buttons, it actually, you know, changed my screen. So I know it is communicating. It doesn't have a problem communicating. It's just not casting the screen on the other side. I can reboot.
Usually, I mean, it would be ideal to have the tablet, but you can probably do most of the questions with mouse pad.
Yeah, I can. But it's easier to display, like, you know, how do you group the instructions and stuff like that using a tablet. But I agree. Yes, I can use, you know, text to describe most of it. Okay, well, I'll leave this one, you know, to do whatever it has to do on the side, and then we'll go take a look at the questions. So this is cisp310. And you guys are having the version A of the test. There's version A and version B of the test. Because I think in the previous test, I found that some people submitted wrong answers, but they're suspicious. Like they're aware of what the other class is having, and then, yeah. So this time I go like, okay, well, make it a little bit different. Okay, let's try it one more time. Okay. This time it doesn't even bring it up. Okay, I got visor set up. Select. Interesting. This time it doesn't even. There we go. It is very strange. Give it one more chance. Ah. It just doesn't want to do it. Okay. I rebooted the machine and it still doesn't want to do it, so I'm gonna have to do it the other way. Alright. Okay, so the first question is basically saying that we have two multiplexers, this one here and this one here, and they're doing something that's related. In other words, they're both trying to control what we use to connect to the program counter to update the program counter. So in this table, I just want you to kind of specify when PC mux is a 0, okay, when you look at this part here, I can zoom in just a little bit so you can view that part of the schematic a little better. So when PC mux is a 0, it will take PC inc, as the input. So we'll just, right down here, this is PC inc or PC incremented when PC mux is a 0. Now, when that is, when PC mux is a 0, it doesn't really matter what our register output 0 enable is because we are not going here. Okay, so in that case, you can use a question mark, and or you can just, use whatever you want to specify here. It doesn't really matter. It's a don't care. Huh? Yeah, any is fine. Put a cross, it's fine. Okay. So now we want to look at what happens. What would connect D, which is the data port of RAM, or register output 0 (RO0), okay, to the input of the program counter. So in order for D to connect, which is this guy here, we need this pin to be a 1, and we also need to connect here. So we know PC mux has to be a 1 in this case. When PC mux is a 1 and we want to use input 1, we also need the RO register output 0 enable to be a 0 in this case. Because of this bubble here, it is a negation to R register output 0 enable. So for the other one, there'll be a 1 and a 1 here. So that's basically the first part. That's obviously is worth partial credit. Okay. So for the second part, I just need you to describe, what is going. How do you connect the new multiplexer MUX3? So I'm not going to draw a picture here because I can't really draw easily with this particular interface. But what I can do is this. So I can basically specify the 4 inputs. Okay. So basically MUX. So basically MUX3 has 4 inputs. It's got input 0, input 1, okay, and then 2 and 3. It also has 2 bits for the selections. So we have MUX3.selection bit 0, MUX3.selection 1. Okay. So the question is, how do we connect all of these bits? And obviously has to relate to this one here. So there are different ways to do it. There's no one particular way to do it. If you want to say we want PC mux to be select bit 0, that works. Okay. So you can basically say, okay, we want this one to be PC mux. That means the other one has to be register output 0 enable. Okay. Now, when PC mux is select 0, that means when bit 0 is 0, we want PC and then PC increment to connect to the data port. Okay. So that would correspond to the even numbers. So this one would be PC inc, and this one would also be PC inc. You can connect the same thing to both inputs. Now you can always kind of say, okay, we can use just one of these, and by forcing the other bit to be whatever, we can make it happen too. But this is the most general answer. This is corresponding to what if PC mux is a 1, and also RO0EN is a 0 in this case. So that would connect to the D port of RAM, and that means whatever is left here is register output 0. But this is not the only way to do it. You can flip the bits. You just change the hookup of the inputs differently to reflect the same thing.
Input 3 just blank.
Input 3 blank.
Or 2, sorry.
Input 2?
Yeah. So
Okay.
0, 1, and input 2 I left blank.
Did you switch user lower the selector PC mux?
You'll get most of the partial credit for that.
Well, because you said unused pins would, and if I have everything covered, then I don't need the 4th bit, right? 4th input.
Okay, so you're leaving this one unconnected, right?
Yeah.
But that means, when register output enable is a 0, then the program counter is not going to get changed.
So what would be the non-used bit, or the non-used connector?
Well, I didn't say there would be any. I just said that if there's any, you can leave it unconnected. Any includes 0.
Which is absolutely brilliant for testing knowledge after that.
But that's not going to be a major point for that.
Yeah, right.
Okay, so question number 2 is the implementation, which means we are not trying to, we're just doing line by line translation, and because I'm not going to run this code, so it's not going to be based on whether the implementation is 100% correct or not. I'll be spotting specific issues like, do you know how to get to a parameter? Do you know how to dereference a parameter? Do you know how to check something is 0 versus non-zero? Do you know how a conditional statement is structured? Do you know how to return a result? Okay, so all of those things are individual. So it's going to make grading kind of difficult because I'll be looking through the code to look for evidence that, yes, okay, I can see that you know how to do a conditional statement, or you know how to compare something to 0, and so on and so forth. So if I were to write this code on the side, which I will use another editor so I can scroll on the other side. Okay, there we go. Alright, so the way I usually do things is I like to, this font may be a little bit too big, I need a little bit more space in this case, so I'm gonna decrease the font size a little bit just so that I get more space later on. So I like to know what is on the stack at any particular time. So when I write the code, I like to do it kind of like this. I know the stack pointer is pointing to the return address itself. I do not know, and I also know in this case, because it's given to me, that we have a parameter P that is also on the stack. Okay, so P is going to have a high address, and the return address is going to have the lower address, and that's how things are organized on the stack. I would do a, okay, this part is up to you, okay? I'm doing a decrement D to reserve for the local variable. So this time we have P, and then we have the return address, and then we have the local variable, which is result. Is that okay? And then what we need to do is to now find out, okay, is P pointing to a null character or not? That is the question. So we need to get to P first. So a CPR CD, okay, so now we have P, return address, and then both pointers are pointing to result. I'm going to use round parentheses to indicate what C is pointing to. And now we need to do an increment C so that C is now pointing to the return address. The stack pointer is still pointing to result. But that's not what I want. I need to increment it one more time. So this time, C is pointing to P or the parameter. Return address is by itself. The stack pointer is still pointing to the local variable result. But C is now a pointer or the address of P. It is not P itself. So I need to dereference once to get to P itself. And okay, so we can do it. We can put it back into C. So we can now do a LDCC. So that C is now, whatever P is. Is that okay? Before C is pointing to P, now C is parameter P. Okay. And then we do LDAC. So the A is whatever P points to. And then we can do the AND AA. If you want to compare to 0, that's fine too. Okay. But AND AA will do the trick. Okay. AND AA is a bitwise AND of A and A, and it's going to set the Z flag in the ALU. So it will come back and say, the Z flag will be a 0 if A is non-zero, and the Z flag is going to be a 1 if A is 0. You can also do it the long way if you wish. So if you want to do it the long way, you can do LDIB with 0, and then do a compare AB. That will do exactly the same thing. Is that okay? All right. Okay. So I'm going to do the long way here. Then we only have JCI, so we'll do JCI here. So JCI is going to go to the else branch. Okay, so we'll say, go to the else branch, and here's the else branch. This is the then branch. The then branch has no choice but to go to the end if branch or the end if label at the very end here. So by doing this, now this particular section is corresponding to the recursive call and storing the result back to result. Okay. So the recursive call, wants to add something to whatever P points to. I have it already in A at this point, right? In other words, A is already whatever P points to, and I know it's going to be useful later on. So in my perspective, I'm just going to save it on the stack, and then I can use it later. If you don't want to do it that way, that's fine too. You can just do the call, and then we'll get back to P later. So do you want me to do it the shortcut way or kind of the longish way? It's up to you. Okay, so we'll do it the obvious way. The obvious way is to deal with this first, and then when we get back, then we get back to this point, okay? All right, so we'll do the recursive call first. C is still P, the parameter P. So that is kind of convenient because now we can just increment C. So the C is now P plus 1, and then we push it on the stack. To push something on the stack, we decrement the stack pointer, do std, and then whatever register holds the content that we want to push on the stack. So now we're pushing P plus 1 on stack, which means now we're ready to call recursively again. Then we do a LDI, return address 1. Okay, there's only one single return address here. You don't have to worry about the name colliding with something else. We're not going to be concerned about that. Decrement D, std. Oh, we need to pick a register here. Let's pick register. Doesn't matter. A. Okay. Then we can go ahead and do the condition. We can now actually go to the beginning of the subroutine that we're calling, which turns out to be sub1, okay? So we're doing it recursively. When we come back here, this is return address 1. When we get back, the first thing we need to do is to increment D to clear the 1 byte that we use for the parameter. And now D is now back to, D is now pointing back to result. Is that okay? Any questions about this part? And A has the return value. So A is the return value of this thing. So what we can do now is to do another CPR CD, okay? And then we increment C twice, increment C, increment C. so that it goes from result to return address back to P. And then we do the same thing as last time. We do a LDBC, and then we do another LDBB. So the B is now whatever P points to. And then we can just do add AB. The A has the result of the recursive call, and then B has the value of what P points to. And then we want to store that to result. But result is pointed to by the stack pointer D, so we can just do a std A, and that concludes the then branch. The else branch wants to store a 0 into result, which can be done by loading A with 0, std A, that would do the same thing. And then at the end if, we're just returning whatever the stack point is pointing to. So this is just LDA with D. Increment D to clear the result itself. And then we do a LDB D, increment D, and JMPB right here. Now there's a shortcut version of this. If you don't want to store result itself independently, that does not need to be stored independently. So that's up to you. Okay, if you say, okay, we don't need to store result. Okay, so I'm going to copy and paste this code and give you the alternative version here. So the alternative version is we don't actually need to store result, so that is gone. Now with that gone, all this stuff has to be changed a little bit. Okay, I'm going to change the comment here. Okay, so CPR CD basically means C points to the return address. Increment C now points to P, and that's all we need. And then we dereference it one time so that we can get to parameter P, and then we dereference it one more time so that we can get to whatever P points to. And then we do the compare. That stuff is the same, and this stuff is the same here. The difference is we don't need to store that. So after the recursive call, when we get back here, we can just do the computation, but we don't need to store that back to whatever the stack pointer points to. So this one, I think I just moved the cursor incorrectly. So this one, it doesn't have to be stored back anymore. And then there's also one fewer increment in C, because we have one fewer item on the stack to begin with. And then over here, we don't need to store into the stack anyway. So basically that would be the end of the code. So that's an alternative. This is the version where result is not stored explicitly, and this is the version where result is a local variable and it is stored explicitly. So I'm going to comment here and say that this one is with result as a local variable, and this one is the alternative of result is not a local variable. Is that okay or not? Kinda? Okay, alright. So that's question number 2. Moving on to question number 3. Question number 3 is asking that you kind of analyze what this code is doing. If it is passed an array of characters representing the last or the rightmost 3 digits of the student ID that is null terminated, you may assume the array that is containing a student ID is starting at location 250. Note that the AND instruction is not hijacked by the increment or decrement instruction. In other words, AND works the way it's supposed to, regardless of which 2 register you specify. To facilitate partial credit, track the values of register A and stack items that are initialized and updated by the subroutine, and also verbally describe what the subroutine actually does. Okay, so when you figure it out, you go like, okay, this subroutine does this, da 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 da. Okay, so I'm gonna start with this one here. Oops, /. So we will say that C points to the return address. decrement D, which means we are allocating for a local variable. Okay, so it seems. So we have some kind of local variable 1 that is allocated at this point. Subtract A from A means we are just initializing A to 0. So A is basically 0. So this part is just saying local variable 1 has an initial value of 0. Incrementing C means C is now pointing to parameter 1, which is the array that is being passed into the subroutine. And now C is actually parameter 1 because I did a dereference. Is that okay? So far? Yep, go ahead.
So I think he went up and asked a question saying, how do we know, like, if we're assuming that the return address is being stored at 249 in the stack?
But we don't.
No. This is actually 250. Parameter is 250 because you were told that the subroutine is passed an array of characters representing the last 3 digits of your student ID that is null terminated, and the array starts at location 250.
Right.
But in C, an array can only be passed by address. It cannot be passed by value. So that's why we know that param 1 is 250.
Oh, so the value of parameter 1, wherever it is in the stack, is 250.
Correct. Because that's the address of your array.
Load A, that means that A is equal to the value of whatever stored at C being 250? So that would be the first thing. Right. Yeah.
Actually, I take it back.
A
A is 250. Yep. Yep. Okay. So in the first iteration, B is whatever is at 250. So this part depends on your actual student ID. So I'm gonna use mine here, which is 887. Okay. So now B is the ASCII code of 7. And then when you end BB, okay, you're just checking whether it's 0 or not. It's not a null terminator. So because it's not a null, you're not going to branch to L2, and you're going to go here. So we get here, C is 1, and we are ending C with B. Okay, so what we are doing here is we're computing. So C is the ASCII code of 7, which is 37 in hexadecimal, bitwise and with 1. What do you think that's going to be? It's just 1. We're doing a bitwise AND, which means we look at each bit of B, register B, and each bit of register C. Bit 0 of C and bit 0 of B are ANDed together. Bit 1 is ANDed with bit 1. Bit 2 is ANDed with bit 2. That's how a bitwise AND operates. Right. So in other words, we are really just isolating what is in bit 0. Okay, that's all we're doing. We're just you're looking at what is in bit 0. Yep.
If I go to the LDB and A.
LDBA.
In parentheses, I thought that would make it assume it's a memory address or something, right?
Yes. So we are dereferenced. So B is basically storing what is A pointing to, right?
Right.
But it is the same thing as dereferencing 250. But 250 has the first byte of your last 3 digit of your student ID.
But doesn't load A parentheses C dereference C, so A is equal to the actual value of dereference?
Wait.
That's what I
Are you
thought.
talking about this line or this line here?
Both. That's things that in that order, to me, it would seem that A becomes the actual value of what's held at 250.
C is the address of 250.
Right. When you dereference the address by putting parentheses, what do you end up with?
Then A becomes 250.
But didn't you dereference C?
C is the address of 250.
And when you put parentheses, you dereference, right?
Then you get 250. So A is 250.
C is some
That is correct.
Okay. I thought 250 was
Yeah,
part of the
that's
stack.
where I got messed up.
Yeah.
I thought 250 was
Yes.
just.
250 is not the actual stack location.
No.
Yeah, that's where I got messed up.
Yeah.
Okay.
That messed me up as well.
What?
Yeah.
I'm not. Okay.
Well, kind of seems on my reading of the question, it seemed like the return address was at 249, and then the array was just on the stack. Like it was just 4 variables on the stack basically at 250, 251, 252, and 253. Or 253 is the
But you cannot
number.
pass an array by value in C.
Yes, but I wasn't. It was.
But we
I was.
weren't.
Yeah, I
There was
was.
no
I was
need to-
seeing it as you were passing 4 characters, not passing an array.
Yeah.
So, on my.
But that's why I drew that picture on the whiteboard.
I think the picture didn't help. I think,
It
I
didn't
think
help.
if I had read this without the picture, I think I probably would have thought it was an array. But with the picture, I was like, oh, okay, he's just loading that on the stack. Because I don't know, it looked like a stack when you drew it. So I just kind of.
So what is the difference between an array and
Wait,
the
so
stack?
you're passing
The array is just-
Yeah.
the address of the first character of the array.
Yes.
And then we're incrementing the pointer to
Mhm.
look at each character, right?
Yes.
Okay.
Basically, it's like, it looks. I was looking at this as we got like basically 4 variables. Each one was a character, but that wasn't what happened. It was we got one variable which was just one pointer. And the actual array itself is somewhere else in memory. Happens to be 250 in this case.
I think if it's just the words, that can be that confusion. But when I drew the picture, I
Yeah.
clearly stated that location 250, 251, and 252 had the 3 ASCII code, and then location 253 has a null terminator. So the array is at location 250.
It was the thing on the top. It was you had like a D and then an arrow and it's
Yeah.
the right address and
Yeah.
then you wrote 250 above it.
Yeah.
That confused me. I thought it was memory location 250 was above it, not the number 250, like not the value 250.
So
I thought 250 was like a line number, basically, in stack, like a stack location. That's what messed me up.
Yeah. I'm still kind of thinking that. Like, there's like an array that block off like an area of the stack.
The array is sitting somewhere. It doesn't even have to be on the stack.
Yeah.
And we were
Well,
past the
we-
pointer to the array.
Yeah, we were past 250.
Then we have the pointer, which means we have a memory address, because we have the stack. So.
Well, no, it might not be on the stack. It could be on somewhere else.
It can be somewhere else. It can be whatever.
It'd be on the hard drive.
Is the stack then
You're given the pointer.
It's the same space, but so
Okay.
I was messed up and I'm still messed up there. You're gonna have to go over all the steps again.
Okay, so
yeah. So one line in the stack, 4 lines here. That's what
Okay.
yeah.
Yeah, fine.
okay.
I think that makes sense.
Problem is it's like that one that like not getting that one line makes the rest of the code.
Right.
gibberish.
I know.
Because suddenly B is
Yeah.
just some random location in memory. Like that's pointed to by the third, like by the third to last number of my student names. The
I
whole
see.
thing is just absolute garbage from there.
Yep. Okay.
That's exactly
Well,
what happened to me.
but that's exactly why I want you guys to kind of comment as you go, so that I can see
yeah.
where your
Remember,
understanding
because
starts to break down.
I mean, I traced it all the way down to where I like almost flipped the table.
I see.
I traced it all the way down straight to a 0 on this question.
Okay, so the bottom line is the subroutine counts how many digits are odd.
Yeah.
Yeah.
That's the basic.
That's the goal.
Yep, that's what the subroutine does. But if the more stuff you leave behind like this, the more chances you can get partial credit, because I can go like, okay, you got this one, you got this one, you got this one. Okay, here's where you didn't quite get it. Okay, you know.
Having a J is equal to.
I
Yeah.
haven't had to fight for
I-
partial credits.
I got
like high school chemistry. I'm not used to it.
Yeah, I got to the point where I was thinking, okay, does dereferencing mean what I think it means?
I know, I did that too.
Okay, well.
So I was doubting my own definitions, and it's like, you explaining this makes it okay. So I did understand it correctly. I just didn't understand the question.
Right, right. Okay, so question number 3, or question number 4. So I'm adding a new opcode with the following, you know, stuff here. So you need to kind of look at this and look at the processor architecture and figure out what slice 0 actually does. So this one means, you know, we are in fact changing the program counter. So the first slice is going to change the program counter somehow. And then you have to look at PC mux mux, which is 7. Now when PC mux mux is 7, PC mux is a 1, and then PC inc is a 1 as well. Okay, so we are incrementing the program counter. So we're incrementing the program counter. We are not using the ALU, and that's why your ALU enable is a 0. We are using register output 1, and we are using register D for that purpose. Okay. We are using RAM because RAM select is a 1, and RAM load is also a 1, which means that it's a read operation. So we are reading from RAM, and then if you track down, you know, in the processor schematic, register D is what is driving the address bus. The program counter is updated because of that. Is that okay? I think PC mux being a 1 means we are okay, this goes back to the first question. So when you go back to the first question, when PC mux is a 1, and our register output 0 enable is a 0, we are in fact using the data bus of RAM to update the program counter, and that's exactly what is going on in question number 4. So I stand corrected because register output enable is a 0 here. So the first slice, okay, so the first slice 0, what it is doing is we are changing the program counter. So the program counter is on the left hand side of the equal symbol, and then whatever's on the other side is basically doing the reference of D. Is that okay?
I mean, yeah, okay is a strong word. Like I understand it looking at it here, but I did not write anything after this question.
Yeah.
Yeah, I did not have anywhere near enough time to even look at it.
Okay.
I was jumping around and I was looking at it, and all I understood was that we were working with RAM in slice 1.
But that's but all of these things are here so that you can look at the components of the processor and figure out which switch is switching which way and how we are connecting the components of the processor. So
Yeah.
this is also, you know, how I said, you have to study for this class is you have to get this part. You have to really understand how the components operate together.
Well, yeah, I mean, I printed out the stuff.
Mm-hmm.
I think I would have gotten this right if I had the time to do it, but I did not.
Ah.
My brain shut down after the last question.
Yeah.
After the previous question, not the last question. This is the second last question.
Yeah.
Okay, so slice 1, okay, so we're moving on to slice 1. Slice 1 is not changing the program counter. It is using the ALU, okay, so ALU enable is a 1. It's specifying operation 0, which is an addition. We are putting a 0 here into register output 1 demux, which means we're using the constant 1 to feed into it. We are using register 3 or register D as the other input into the ALU. And we are also updating register D as a result. So this one is really just incrementing D. So it's the same thing as this. Okay. So in the end, this is what the instruction is doing. We are copying whatever register D or the stack pointer is pointing to into the program counter, and then we are incrementing the stack pointer. Is that okay? Okay, it's a strong word. Okay. So what instructions does it replace in question number 3? Those 3. It's basically a return instruction.
Okay.
It's better than these 3 instructions because it doesn't modify register B. So it basically leaves the register B alone, but it accomplishes the same thing. Alrighty.
Would implementing that suddenly make your code not risk, or your assembly not risk?
As we implement it, exactly, because it can be done with more primitive instructions. Sometimes there's a trade-off, because the whole idea of RISC is to improve the energy efficiency of the processor. So if by doing this the energy efficiency is actually improved, then it's worth doing. But if by doing this, at some point, the curve is going to go like this. So after the intersection of these 2 curves, then it's not worth doing anymore because you're actually introducing too much silicon, and it's not saving energy anymore.
Considering that most of modern programming requires a lot of return statements, it would probably be pretty efficient to go ahead and implement that.
Yeah, well, we have the space to do it. We have enough opcode to do it.
Well, because this is 2 lines of microcode, right?
Yep.
As opposed to the other things which would be 3 or 6.
Okay, if you count the total number of slices of microcode, this is terrible. Because you got one fetch, right? Location 0 of ROM, location 1 of ROM, and then whatever this instruction is, the 3rd one, and then resetting. So even if you don't count resetting, there are 3 slices of microcode here, 3 slices here, and then 3 slices here. So you're talking about 9 slices of microcode to get these 3 instructions done. With this one, you have the decode, we have the next instruction, and then we have the 2 slices, or 3 slices, 4 slices here. So we are talking about 4 slices of microcode versus 9 slices of microcode. So it's a pretty big trade-off.
Well, you are implementing this, though. You are kind of losing. You're kind of specifying that D has to be the return.
That is correct.
Whereas
So D is no longer.
Kind of like, you can build it
Yep.
on one turn.
Exactly. So by doing this, we are now we are looking at D as what we call a special purpose register, which means only certain instructions would use register D in this particular way, as opposed to treating register D as, oh, it's just another register, we can do it.
Registers, they do whatever.
Exactly. Yep. So it's a trade-off. That's all it is. Yep.
I mean, that's all of computer science, really. It's all a trade-off. We tricked a rock into thinking,
Yep.
and now we're trying
Okay, so this is the monster, that we have to kind of figure out what it does. Okay, so so I would do it kind of like this. I would figure out, so C points to the return address at this point. We allocate for a local variable of some kind, because every time you decrement the stack pointer after we get into a subroutine, we are probably allocating for a local variable. Now C points to parameter 1. We don't know what parameter 1 is. Now A is parameter 1. And this time we are checking whether parameter 1 is 0 or not. So we are basically saying if parameter 1 is 0, then we want to go to L1. Okay? And this part is the else. Okay, so this is the else. Okay, if parameter 1, okay, so parameter 1 does not equal to 0, we get here. So B is pointing to the local variable in this case. Yep, okay. I have to read it a little bit myself here. Okay, so then the next 2 instructions is pushing the address of local variable. In other words, we know that from this instruction, b is the address of the local variable, and then we decrement the stack pointer, and then we store whatever b has onto the stack. It is the same thing as pushing the address of the local variable on the stack. We decrement a here, so we have to ask, okay, what is a? A is whatever the parameter is. Okay, so param1 is this thing here. So we are basically saying a is param1 minus 1, and then we push it on the stack. So these two instructions is pushing param1 minus 1 on the stack. And then we specify label L3, which is our return address, and we push that on the stack too. So now we are pushing return address L3 on the stack, and then we call sub1. So this is basically calling sub1 again, but with two parameters. So the first parameter is the last one that we push on the stack, which is param1 minus 1. And then the second parameter is the address of local var. So now at this point, we know sub1 has two parameters. Not one, but two parameters. These two instructions together, they are just deallocating params of call. And then this one here, when these two are cleared, D is once again pointing to the local variable. So so B is local variable. And then we are doing some calculations. So we'll go ahead and say, okay, what is going on here? C points to local variable, which is the last thing that we allocate on the stack. Incrementing it will make it point to the return address. Incrementing it one more time, it will point to param1. And then we basically want A to be actually param1 here. And we are adding those two. So B is local var, A is param1. So now we are saying A is param1 plus local var. We increment C. C is param1, last time we checked. So C is now the second parameter, which is the address of something because of this. Okay. So C is now pointing to param2. And then C is param2 at this point because we dereference it. And then we store A to whatever C points to. So we are dereferencing param2 in order to store param1 plus local var.
So we can assume at this point that param2 is pointing to a location like a hard drive or RAM or something.
It's pointing to a location in RAM.
Okay.
Yep. And then jump to L2. So when you look at the structure, L2 is here. So that's the else. Basically, that's the end if. Okay. So this is a jump to end if. This is the else branch. Okay, this is the else branch because we got here because of the JCI here. So the else branch here is when this is where we branch when param1 is 0. Okay, that's the else branch. So we increment C, so we have to kind of track at that time what C has. So at that time C points to param1. Okay, so C now points to param2, and then we dereference C to A. So A is param2 at this point, and then we subtract B, which means B is just 0. And then we store B to wherever A points to, which is dereferencing param2. We're just doing that, basically. Okay? This is the end of the if. So by the end of if here, we are incrementing D to deallocate local variable, local var. And then we perform the branch back to the caller. Okay, so the next three instructions are return. So the question is, do we have a return value? Does this subroutine has a return value? Does it have a return type? How do we use A, register A at the very, very end of this subroutine? We overrode it with the return address, which is not going to be useful as a return value. So this subroutine has a return type of void. So this is the conclusion. It's a void subroutine. The first one, now I never really kind of indicated, there were no JCI or JLI, so I cannot tell whether it's signed or not. So if you say it's int, it's good. If you say it's unsigned, it's just as good. Okay, I cannot take any points off. There's no indication whether it really should be int or unsigned. Okay, so int is fine. So we got param1, which is just an int. The next one is a pointer. And then in the subroutine, the first thing I check is whether param1 is non-zero or not. If param1 is non-zero, I do a recursive call with param1 minus 1 as the first parameter, but then I would also use my own local variable here, or the address thereof, as the second parameter. Otherwise, we basically specify param2, whatever param2 points to, we get a 0. Oh, after this, we also have a param2 is param1 plus local var. So that would be the entire subroutine. I'm not expecting anyone in class to actually get this one 100% right. No, seriously. Seriously, I'm not expecting that. I'm expecting people to get pieces of it done correctly, and there will be like multiple line items corresponding to this question, and each one has, its own A, B, C, D, F, and I'm expecting people to get some of these, but not the entire thing. This one is kind of a more difficult question. But it can be done in a way to get partial credit too. Are there any questions? Okay, so getting back to that question that was really confusing. This one is not confusing in many ways because there's no assumption. So getting back to the one that is really confusing, like this one here, if I gave you the caller code, would that be better?
What?
The caller's side of the code, would that be better? If I give you main and this is how the subroutine is called?
If you gave me a function header, I probably would have gotten 100 points.
A function header.
If you gave us a function header for what the C code that generated this was, I probably would have gotten 100.
Well, that's the whole point. I want you to reverse engineer what it's doing.
Yeah, but if you just given us the header, then I could have filled out everything else.
Mm-hmm. Okay.
I think that was.
I just got stuck with the whole location. I was really fixated on the fact that it was in the stack somewhere.
Yeah, I mean, if you had just said, if you had said where you may assume the array starts at location 250 in RAM or something, or
The whole thing's
something like that, instead of me assuming that was on the stack, that may have helped quite a bit.
What
Just-
is on the stack? The array?
Well, it's saying that it starts at location 250.
Yeah.
Where is 250?
Is it on the stack or is it on RAM?
well, the stack.
The stack is in.
It wasn't on the stack.
But
There's
yeah,
no.
it's fine.
There's nothing else that has location 250 except for the ROM. I mean this, but this question is not about
Yeah, it's
the microcode slices. So there's only one. There's only one component of the entire processor that has locations. And that's the RAM.
Oh, dear.
Yeah, I thought it was past everything where it's reverse order and then return address. And so when you start incrementing down, you start
Okay.
reaching the array.
Okay. Well, maybe.
Kind of just like, I mean, I think there are a lot of ways. There are a lot of like single words that probably could have been thrown in there that would have made me get this, but I can't necessarily hear. You know what I mean? That may not work for everyone else. I think if you had said is past a pointer, then I would have gotten it. If you give me a header, I would have gotten it. If you know what I mean?
Mm-hmm.
Like any
You
one
mean-
thing, I might have gotten, but I
pass a pointer to an array.
Yeah, or even just a pointer.
Okay.
You just said is past a pointer, and then just or a pointer to a series of, like, to a null terminated list of characters or whatever, a null terminated array of characters. Just anything in there that, like, tells me it's definitely a pointer.
That's kind of what I wanted to do with the picture that I drew in the class, but that well, that didn't seem to be helping.
It backfired a little bit.
Backfired.
At the same time, though, I think everyone has a different. It was kind of just in the absence of small pieces of information, we were just trying to visualize it. And so, if you draw something that to me looks like how I draw a stack, you know, oh, cool, it's on the stack, and I'm just going to start.
Well, I was thinking the stack tends to start at the back end.
I will next time. I think I'll supply the actual the caller code, so that way it cannot be wrong. I mean, that's just exactly how it's done. I actually test ran all the code, all the assembly code. I test ran every single bit of code in this test.
It didn't work.
Yeah.
Oh, sometimes I did not do that. Sometimes I neglected to do that, and the code actually does not work. But in this exam, everything works the way they're supposed to. It's just the way I asked the question may not be, maybe slightly confusing. This one I think is not too bad.
That one.
I mean, you have a lot of partial. There are a lot of partial credits here, because I'm looking for individual stuff like do you know how to do a conditional statement that has an else? Do you know how to dereference a parameter? Do you know how to get to a parameter? Do you know how to specify the return value of something? Do you know how to do a recursive call? Do you know how to dereference again and specify the return value? So with this one, there are a lot of independent pieces, and each piece has its own partial credit scheme. So I think this one is not too bad.
Right. Okay. So the if pointer p, that's supposed to be saying that we're comparing it to see if it's non-zero. That messed me up. I saw if pointer p and I was like, this what?
That's a C thing. So that's why CISP360 is a prerequisite of this class, because it is implicit that is what it's asking for.
Yeah.
Yep.
I left my results in register A rather than assigning it to a
Local variable?
local variable.
Yeah, that's fine, because that's exactly why I went through 2 iterations.
Right,
In the
right.
second iteration, there's no explicit result as a local variable
Where'd you leave it?
in register A.
Oh, you did?
Yeah. Yeah.
See, yours is a lot longer than mine, which means that there's probably some bugs that'll show up in mine where you put in the wrong information, it just goes poof.
Not necessarily, but I do not always use the shortest possible code when I explain this.
Well, the way I did it was I had one loop with a jump with a break if it ever saw a 0 was the way I did it, instead of doing an else.
No, so you didn't do recursively?
No, I just looped.
Oh, okay.
And so then I would just load in what was available, add that to register A, then check if it was a 0, because adding 0 to A wasn't going to affect it, and if it did see a 0 after adding to A, and because again 0 is not going to affect that A, it'll break if it's 0. If it's not, then it'll jump again. Does that make sense?
But then it is not following the recursive call. Then you won't get all those points, because this one is designed the way it is to see if you can write the code from the caller's perspective to call the subroutine recursively. I mean, obviously this doesn't have to be recursive because I'm just adding all the bytes together, right? It can be done with a while loop, but I do it this way because I wanted to see if you know how to do a recursive call.
And then I ended up running over my own thing where I was trying to protect the return address and like, don't touch this. I still like doing the whole thing where you just use C as the pointer and leave D alone, but I can't do that if I keep copying over D to C. I mean, I guess I could, but then I would never get anywhere. No, yours has a solution, obviously. Just in my head, I don't know.
Okay.
about it. I like my lead version. It was better. Always use Loser.
But it's not going to be doing what this code is
I know,
specifying.
so
So
I'll give partial credit because it'll work, but it'll be wrong.
Yeah.
okay. So now you have it. You know the what I was asking, what I in my mind, what I was looking for.
Well, I learned something today at least. So.
I know.
So you doing okay?
No.
No.
I'm really concerned.
I'm pretty sure everyone in our class is going home to cry a little bit.
Yeah.
We're going to work and cry on the inside.
I get to drive for 8 hours.
This is one test that actually might be beneficial to grade on a curve.
Right.
But it's not curved, right? You said that. You said you're just going to drop the lowest scoring
Well, it feels
problem.
the same.
It's not curved.
Well, maybe 2.
Oh, God, please. How do you decide that? You just gauge what the class did.
I look at the ratios of A's and B's, basically.
Okay.
I would like the class to have, when I add up all the A's and B's, I want that to be the majority of the class, more than 50%.
Oh.
So if I drop one question and it doesn't bring the ratio to, when I add up the A's and B's, it's at least 50%, I'll drop another question.
So essentially
So
saying
there's going to be
that-
one question on
I'm certainly
Everyone's
hoping
gonna
it
get
doesn't
100
boil
if the
down
only
to
question
only
you don't
one
drop is
question,
gonna be-
because that would not be good.
So essentially what you're saying is that you take
shows.
essentially that if the class does not, in general, is not holding to a certain standard, then therefore the flaw must be with the test, and that's why you're
Yep.
decreasing the or taking off the lowest scoring from the grade
Yep.
to thereby compensate for the test
Yeah.
being flawed rather than the class.
Yep. Yep. Pretty much. So I only use curving when the score is, too dismal.
Yeah.
As opposed to, in some other universities, they would do the opposite. The whole class can be getting like 80s and 90s and go like, no. We only have 5% of A's and maybe 10% of B's. The rest you can get C's and F's.
Yeah, engineering classes we always liked curves.
At which university?
At Davis.
Yep, and Davis models after Berkeley. Yep.
We liked the curves.
Yep, Davis